So hello everyone, here we are going to do 3 problems on optics. In optics we have ray optics and we have wave optics. And for NEET, if you go to see in wave optics, we have Young's double slit experiment, we have diffraction, and then normal ray optics, which you usually have in 11th standard. So I'm going to solve one problem of each type which have come for your exams. So remember, all the problems that I'm going to do are all your exam problems itself, that is your NEET and PMT problems. Now if you look at the first problem we will take it from Young's double slit experiment. Now if you can notice, it has come in NEET 2018. The objective is to tell you how important a very simple formula will become so that you can easily solve. Now looking at the question, very lengthy, half of the students will skip looking at the question itself. But it's very easy, you just have to extract one formula out of this. So let us start. What is said is, in Young's double slit experiment, so the first indication is you have understood the topic. The separation small letter d between the two slits is 2 millimeter. Therefore, I know the separation small letter d is 2 millimeter. And if you look at the options, all options are given in millimeter. Therefore, I don't need to convert into SI unit. Now, they are asking what is the wavelength lambda. Wavelength lambda is given as 5896 angstroms. So, wavelength is given as 5896 angstrom, and the distance capital D between the screen and the slit is given as 100 centimeter. Now if you notice one thing in this question, all the distances, all the length are given in 3 different units. For example, I have got small letter d in millimeter, lambda in angstrom, and capital D in centimeter. Now the actual question starts. What they are saying is, it is found that the angular width of the fringes is 0.20. So first thing you should know is the formula for angular width in Young's double slit experiment, and that is given as 0.20. Now if lambda by d is 0.20, do I know the value of small letter d? Yes. So value of small letter d is 2 millimeter. If I substitute, I get 0.2 is equal to lambda by 2. Therefore, I get the value of lambda as 0.2 into 2. Now, this lambda is used and not the question lambda is a thing you should consider. Why did we find out lambda? Because we have to find out angular width, for which I will need a separate lambda. Now what they are asking us, they are asking us to increase the fringe angular width to 0.21. That means now they themselves are telling us that lambda by d is now 0.21. So if now lambda by d is 0.21, then what is small letter d? How do I know they are asking small letter d? They are asking separation between the slits. I want to find this. Okay, do I know lambda? Yes, I just found out. I know what is the angular width, so I'll take d on this side and I will get lambda upon 0.21. Now what is lambda? Lambda is 0.2 into 2, which is 0.4 upon 0.21, which is almost 2, not yet 2. It is 1.9. And since small letter d is in millimeter, my answer will be 1.9 millimeter. Therefore, my answer will be B, which is 1.9 millimeter. Now, if you notice in this question, the only formula that I used is angular width for Young's double slit. And angular width formula will be lambda by d. And that small letter d is distance between the slits. Nothing else was required in this whole question. We are just using the formula angular width equal to lambda by d twice. We are using this formula twice. That's it. This is how easy the question of Young's double slit is. Now the same questions of Young double slit have been asked in various years. Try to solve them. Okay. Now let me go to the next one, which is a diffraction problem. Now please look at the screen for diffraction kind of problems. This was actually your PMT 2014. Let us start. A beam of light of lambda 600 nanometer. Now 600 nanometer means, if you look at the screen, lambda is 600 into 10 power minus 9 meter, from a distant source falls on a single slit 1 millimeter wide, and the resulting diffraction pattern is observed on a screen 2 meter away. That means if the screen is 2 meter away, that is small letter d and capital letter D are given, and if you are confused as to which is small letter d and which is capital letter D, first thing is, from the theory, that distance between the slits is small letter d and distance between the slit and the screen is capital letter D. But if you are still not aware from the theory, the smaller value is always small letter d and the bigger value is always capital letter D. Now they are asking what is the distance between the first dark fringes on either side of the central bright fringe. If we have a central bright fringe, we need to find the distance between the two dark fringes, or in other words, they are asking us width of the central maximum. So 1 above, 1 below, therefore the width will become lambda d by d plus lambda d by d. It will become 2 lambda d by d. Okay, why 2? Because 1 above and 1 below. Therefore, the total width will become 2 lambda d by d. 2 is a constant. Lambda is given in the question. Capital D is also given in the question. Small letter d is also given in the question. Therefore, if you substitute the given values in SI units, you will get the answer as 2.4 into 10 power minus 3 meter. Now 2.4 into 10 power minus 3 meter, if you look at the options are in centimeter and in millimeter. Now since you got 2.4, option A and option B will automatically be out. You will have option C or option D. Now 2.4 into 10 power minus 3 is 2.4 millimeter itself. Therefore your answer will be D. Okay, now this is the question from diffraction. Now coming to a question from ray optics. This is your NEET 2017 question. They have said that the ratio of resolving powers of an optical microscope of two wavelengths. So they have given two wavelengths. One is lambda 1 and one is lambda 2. Okay. Now they want lambda 1 by lambda 2 is given. They want resolving power 1 by resolving power 2. The main thing you should know is, from your theory part of 11th standard, that resolving power is inversely proportional to wavelength. Okay, in optics you have focal power, focal length, okay, which is inversely proportional to power. Your resolving power is inversely proportional to wavelength. Therefore, I know my resolving power is inversely proportional to wavelength. That means resolving power 1 will be inversely proportional to wavelength 1, and resolving power 2 will be inversely proportional to wavelength 2. Therefore, if I take the ratio of resolving power 1 is to resolving power 2, resolving power 1 is to resolving power 2, I'll get exactly opposite, which is lambda 2 by lambda 1. And in the question, lambda 2 is given as 6000 and lambda 1 is given as 4000, which is nothing but 3 by 2. And the option which matches is my option B. Just see this. Okay, with such a simple logic, you get 4 marks in your exam. Okay, so please understand the simple formula that you need is resolving power is inversely proportional to wavelength.